Hi, welcome to Lesson 22, Session 1. Today we are going to explore multiplying fractions in word problems. Now, for the last several weeks, we've really been working with multiplication, multiplying fractions, and we really have a solid foundation of how to multiply fractions. But now we're going to put it into practice and find out some real life applications and ways that we can multiply fractions. So we are going to be working in our Ready Classroom Math Workbook on pages 437 through 440. So go ahead and turn to page 437 now. It says this. Let's get a little bit closer. There we go. Now that you have learned how to multiply fractions, you will use what you know in problem situations. Use what you know to try to solve the problem below. So here is the problem that we are looking at. It says this. Maybe. Let's go ahead and focus. There we go. All right. Grayson lives 4/5 of a mile from the park. He has already walked 3/4 of the way to the park. How far has Grayson walked? Use a visual fraction model to show your thinking. So first of all, what is this problem talking about? What is it that we're trying, what's this whole problem even about? And this problem is about the park and Grayson. And Grayson's going to be walking to the park, okay? And so we want to find out how far has Grayson walked? And then the important information is that he lives 4/5 of the way of a mile from the park. And he's already walked 3/4 of the way from his house to the park. So that's what we know. So if I were going to use a visual fraction model, what I would do, and I think would probably be the best, would be to go ahead and make a quasi number line. So first I'm going to draw this house. In this house here is where Grayson lives. So this is where Grayson lives. And then over here, we're going to do a little swing set. That's a terrible swing set, but you get the idea. And that swing set is the park. So if we start here at Grayson's house and we go all the way over here to the park, we know that Grayson's house would be 0. And the park would be at 4/5 of a mile, because that we know that the park is 4/5 of a mile from Grayson's house. Now, that's all we need to know so far. The other important piece of information is we're trying to figure out how much is 3/4 of 4/5, or how much is 3/4 of this line. So the equation we're trying to solve, or the expression, is what is, oops, not 3/5. Gotta move there we go. What is 3/4 of 4/5? In other words, what is 3/4 of this 4/5? So what we're going to do is we're going to look at this denominator, and we're going to break this section up into fourths. So if I want to break the section into 4 parts, that means I need to draw 3 lines. So I'm going to draw 1 line in the middle, 1 line in half of that, and 1 line in half of that. So now I've broken this into fourths, and now I'm going to shade in 3/4. So I'm going to shade in 1/4 of 4/5, 2/4 of 4/5, and finally 3/4 of 4/5. Now, if I went ahead and drew past the park over here, and I went to 1 whole, or 5/5, that makes it so each of these sections is worth 1/5. Because we have 1/5, 2/5, 3/5, 4/5, and then 5/5. So if we want to find out, we know that Grayson walked 3/4 of 4/5, which, that should have been 3/5. Look at me. I even knew that it was 3/5, and I wrote 3/4. There we go, 3/5. So if I solved what is 3/4 of 4/5, the answer is, it's going to be 3/5. Now, if I were doing that as an equation, let's see what that looks like, because I wonder if an equation would look the exact same. So if I'm trying to solve 3/4 of 4/5, remember that of means multiplication. So the equation is, what is 3/4 times 4/5? So if we solved that equation the way that we know how, by multiplying our numerator times our numerator and our denominator times our denominator, we would get 3 times 4 is 12. 4 times 5 is 20. Now, this is interesting because we got our answer as 20/12, but up here the answer we got was 3/5. Do those things mean the same thing? Yes, they are equivalent fractions. What that means is this fraction here is right, and so is this fraction here. This fraction can be reduced to a simpler form. So the way that we reduce fractions is we find an amount that both the numerator and the denominator can both be divided evenly by. So in this case, I know that 4 is a common factor for 12, and I know that 4 is also a common factor for 20. When I divide both the 12 and the 20 by 4, I get 12 divided by 4 is 3. 20 divided by 4 is 5. So look at that, 3/5. So now you can see that we were right up here in our picture with the number line that we drew. We showed 3/4 of 4/5, and we got an answer of 3/5, which is our answer down below. Now, some of you, your best method is going to be just simply doing the equation, and some of you might like to draw the picture. In this case, it asked us to draw the picture, so that's why we went with that option. Go ahead and turn to page 438. So now that we're on page 438, it says this. Explain how you can use a visual model to show how far Grayson has already walked. So I wrote this. It says, if we use a number line, and you should write this in your book, if we use a number line, we can show his house 4/5 from the park. Then we can find 3/4 of 4/5 to see how far he has walked. Now, looking ahead, we're going to go ahead and look ahead and see what we've got going on here. So it says this. You can use what you know about multiplying fractions to think through and solve word problems involving fractions. Consider this word problem. Aaron spills 1/2 of a 3/4 pound box of cereal. Yikes. I don't think Aaron's mom would be very happy. How many pounds did she spill? So if she had a box of cereal, and that box of cereal was filled 3/4. So this is 3/4 up here of the box of the cereal. And then Aaron accidentally spilled half of what was in that box of cereal, and she spilled it onto the ground. We want to know, how much did she spill? How much fell out of her box of Cheerios? So if we find 1/2 of a quantity, it's the same as multiplying by 1/2. What equation could you write for the cereal problem? Use P for the unknown amount in the problem. So we know that she had 3/4 of a box of cereal. Then we know that she spilled, I'm going to do it the other way around. We know that she spilled half of it. So we're trying to solve what is half of a box of cereal that is 3/4 of the way full. So we're going to remember that word of also means multiplication. We can multiply. So we want to know what is half of 3/4, and then the answer is P. That's our product. That is the amount that she actually spilled. So if we know both factors, we just don't know the total amount or the total product. So the P is our unknown amount. Now part B says this: estimate the product. Is the amount of cereal Erin spills on the floor more than 3/4 of a pound or less than 3/4 of a pound? Why? So we know if we have a half a pound and we multiply it by 3/4 of a pound. Okay, we need to look at this half of a pound, which I just made look a little crazy. Is this number less than, greater than, or equal to less than, greater than, or equal to 1? That's right, it's less than 1. So if this fraction is less than 1, that tells us that our product of these two fractions will be less than 3/4 because 1/2 is less than 1. Hopefully you can see that over there. So we know that our product will be less than 3/4 because 1/2 is less than 1. Now, if this had been 1, then we would have spilt all of the cereal and we would have spilled 3/4 of a box or 3/4 of a pound of cereal. Now, could we have had, is it possible to spill more cereal than you have in the box? No, it's not. So we know that it has to be less than because we can't spill more cereal than is already in the box of cereal. So now for part C, it says complete the area model to show the problem. How many pounds of cereal did Erin spill on the floor? So we've already have 3/4 on the top, and we're going to put our half over here. Now we'll start with the 3/4. With 3/4, we already have it broken into 4 columns, which is our denominator, and we're going to shade in 3 sections because our numerator is 3. So we're going to shade in 3 of these fourths that we've drawn. So right now, the yellow section shows 3/4. Then we're going to do our 1/2. Now we're going to break it into 2 rows because our denominator is 2. And then we're going to shade in 1 of those rows because our numerator is 1. So we're going to shade in 1 of these halves. And then our overlap is the answer. So the shaded part is our numerator, which is 3. And then the total number of tiles in the whole is our denominator. So 1, 2, 3, 4, 5, 6, 7, 8. So the answer is 3/8 of a pound is how much of the cereal that Erin spills. Another way we could solve that would be if we just multiplied the equations. What is 1/2 of 3/4? 1 times 3 is 3. 2 times 4 is 8. And so that's just a quick way to check and make sure that our area model is drawn correctly. Now we're going to look at this reflection. How does writing an equation, making an estimate, and drawing a model help you think through the problem? So I want you to use this sentence frame. It helps me because, and then I want you to tell me how it helps you. You're going to go ahead and pause the video there. And then when you're done, you'll unpause the video and move on to the next page so we can fill out the graphic organizer. All right. Whenever we're working, we're thinking about what we know about a fraction of a fraction, meaning a fraction multiplied times a fraction, because remember that of means multiplication. So to find a fraction of a fraction, you can multiply the two fractions. So in this example here, we find that 2/3 of 1/2 in this case would be 2/6 because we drew an area model and we showed 1/2 in columns, meaning we made 2 columns and then shaded in 1/2 of it, or one column because the numerator is 1. And then we drew 2/3 on the side. We broke it into 3 rows, and then we shaded in 2 of those rows because our numerator is 2. In this example over here, we're showing what is 1/3 of 3/4. We drew a number line from 0 to 1. Then we drew this bar to show 3/4. Then we took 3/4 and we broke 3/4 into thirds because the denominator here is 3. We broke it into 3 sections, and then we shaded in 1/3 of 3/4. So how much is 1/3 of 3/4? It is 1/4. A couple more examples. 3/4 of 1/2 equals 3/4 times 1/2, which equals 3/8. 2/3 of 5/6 equals 2/3 times 5/6, which equals 10/18. So what I'd like you to do on your own is to go ahead and write in your own example. Write in 2 fractions that you'd like to multiply, and you can either make an area model, you can simply do the equation, or you could draw a number line. Go ahead and do that here in the examples section. Then you're going to go forth after you're done and finish number 2 on this page, number 3 and number 4 on the following page. As always, if you have any questions, you can email your teacher.